Welcome to 3.3 Properties of Logarithms. The first change of base formula, which is becoming a little antiquated with all the technology we have, but oftentimes you're in an environment where using base 10, so for instance using log base 10 or using ln are advantageous to us. ln in calculus is almost exclusively used versus log base 10. But in this case, using change of base, let's say we had log base 3 of 4x. And maybe we don't want to work with log base 3. We could rewrite this as either log base 10 on log base 10 or ln on ln. This could be written as ln of 4x over ln of 3. And the reason we might do that is maybe we just need to be an ln. Calculus-wise, that happens a lot. Or maybe we have a calculator and accessing log base 3 is either not possible or not convenient. These things are going to be equivalent, as is log base 10 of 4x on log base 10 of 3, And kind of easy to remember, it's just, this is our top 4x, this is our bottom 3, 4x on top, 3 in the bottom. Okay. Then properties, and there's some good explanations of these properties, which I'm not going to go into in much detail. Just suffice it to say, this is an exponent and this is an exponent. When do we add exponents? We add exponents when we have something like, let's say, x squared times x to the third. When we have a product with common base, we add exponents, x to the 2 plus 3 or x to the 5. So here we have a product. We're dealing with exponents. When do we add exponents? When we have a product, u and v, with common base a. So this can be split into that, or vice versa. That can be reversed into this. Probably just worth memorizing these. Okay, and then natural log works the same way. When do we subtract exponents? Well, if I had x to the 5th on x to the 2nd, I would get x to the 5 minus 2. And when do we subtract exponents? When we have a quotient with common bases, we subtract the exponents. And in this case, I'm going to take this n, which is an exponent, and multiply it by an exponent. When do we multiply exponents? If I have x to the 2nd to the 3rd, an exponent with an exponent, here we have an exponent with an exponent becomes the product of the exponents. Same for ln. Okay, rewrite the logarithm as a ratio of common logarithms and natural logarithms. Common logarithm, that's log base 10, and I wrote it as base 10 up here, but typically we just call it, this is exactly the same as plain old log 4x on log 3. So A has common logarithms. This thing equals log x on log 1/4. B has natural logarithms. It's ln x on ln 1/4, and that easy. Okay. Evaluate the logarithm using change of base formula. Round your result to 3 decimal places. Now, we could probably go into calculator and use log base 20, but we could also call this ln 175 divided by ln 20. So let's take a look at that. So darken this up a little bit. Trying to get my zoom condition right here. So we have ln 175 divided by ln 20 and rounded to 3 decimal places. Easy enough. 1.724, approximately equal to. Okay, rewrite the expression in terms of ln 4 and 5. I want to turn 500s into 4s and 5s, and I can use multiplication or division for those. So I'm going to make this, let's go 500. Well, that factors into a 5 and 100, which factors into a 5 and 20, which factors into a 5 and 4. So this could be written as ln 5 to the third times 4. That's clearly still ln 500. But I want to have just plain old ln 4 and just plain old ln 5. I can use a rule 1 where there's a product. You can turn that into a sum. And I've got 5 to the third times 4, so that's ln 5 to the third plus ln 4. And that's good. I've got a plain old ln 4. Now I need a plain old ln 5. Well, I can use rule 3, which says if I have logarithm of something to an exponent, I can pull the exponent out in front. So this becomes 3 ln 5 plus ln 4. And now it's in terms of ln 5 and ln 4. I have 3 ln 5s plus 1 ln 4. A little bit sneakier, I can use rule 2 on this to turn this, when I have logarithm of a quotient, I can subtract the logarithm top minus bottom. This becomes ln 5 minus ln 2, and I love ln 5. That is most definitely in terms of ln 5. But ln 2, well, I could think of that as, in terms of 4, I could think of that as ln square root of 4. And ln square root of 4, when we're using logarithms and radicals, we would much prefer those to be written as exponents. And this is to the 1/2 power. And now a rule 3 allows me to pull that exponent out in front. So I get ln 5 minus 1/2 ln 4. Okay. All right, this is kind of along the same line. I like this problem these problems quite a bit here. I'm going to get it over here. I've got a shadow today. Approximate the logarithm using the properties of logarithms, and they give us values for log base b of 2, and they give us values for log base b of 3 and log base b of 5, which means I want to write 30 in terms of 2s, 3s, and 5s. So let's see. 30 is 2 times 15, and 15 is 3 5, so this could be written as log base b of 2 plus log base b of 3, and I ran out of room here, that was bad, plus log base b of 5 when I make this intermediate step here. Log base b of 2 times 3 times 5, I can use rule 1 to separate those all into addition. And log base b of 2 is 0.3562, and log base b of 3 is 0.5646, excuse me, and log base b of 5 is about 0.8271, and I'll leave that sum to the viewer. You can go ahead and run that through your calculator. Okay, as I mentioned just prior on problem 24, if we have radicals mixed with logarithmic statements, we would probably rather have that as 3, in this case to the 1/2 power, which is 1/2 log base b of 3, or 1/2 log base b of 3 is given 0.5646. And I will leave that calculation to you with your calculator. Okay, let's take a look at exercises 69 through 84. Use the properties of logarithms to condense the expression. So we're going to try to smash these things all together into just a single logarithm. So logarithm subtraction, when I got a log minus a log in the same base, log minus log can become log of the quotient in the same order. So this can be written as log base 5 of 8 on t. Condense the expression. 76, well, rule 3 allows me to bring this to a number out in front can come in as an exponent. So this can become ln x squared plus ln x plus 1. And when I have ln plus ln, that can be condensed into single ln of the product. So that's ln of x squared times x plus 1. You might want to do that. Okay, so rule 3, ln x cubed. Rule 3, ln, I believe that's a y squared minus rule 3, ln z to the 4th. Rule 1, I can smash these together, the plus together as a product. ln x cubed, ln x cubed y squared minus ln z to the 4th. And rule 2, when I have ln minus an ln, I can smash those together as a single ln of a quotient. And that's it. And 82, fighting that shadow. I think I'm going to distribute this 4 in here. 4 ln z plus 4 ln z plus 5 minus ln z minus 5 to the 2nd with a rule 3. I'll rule 3 these guys as well. That's ln z to the 4th plus ln z plus 5 to the 4th minus ln z minus 5 to the 2nd, bad z, and that becomes a single ln. The sum terms go in the numerator. The difference goes in as a factor in the denominator. And you may want to challenge yourself to see, hey, could I have just gotten from here to there in one step? I found that a lot of students of the abilities we have in this course are able to do that very quickly in one step. Okay, find the exact value of the logarithm without using calculator. Now, what is a logarithm? A logarithm is the exponent. So this thing is the exponent that turns its base into its argument. What is the exponent that turns 6 into 6? Well, of course, if this is 6 to the 1st, this must be 1. So this whole thing just equals 1. What is the exponent that turns 5? This is the exponent that turns 5 into 1 on 125. Now, hopefully, we recognize 125 as 5 times 5 times 5. So this is log base 5 of 1 on 5 to the 3rd, which could be written as log base 5 of 5 to the negative 3rd. And wow, this one, giving this problem at this stage to somebody who understands logarithm would be like giving this problem to a good Algebra 1 student. What is 7 times x divided by 7? And we'd all know that's x. Well, this whole thing is the exponent that would turn 5 into 5 to the negative 3rd. What is the exponent that turns 5 into 5 to the negative 3rd? Well, negative 3 is. Okay. 94. This is the exponent that turns 4 into negative 16. 4 to the what power equals negative 16? Well, I can't use an exponent. If I put a negative up here, like -2 might be tempting. If I put a negative, 4 to the negative second is 1 over 4 to the positive second. I can't get negatives out of here. There is no solution. Now, I believe in 96. We could come up with the power, the exponent that turns 4 into 2, because square root of 4 is 2, or that is 1/2. We could probably do the same. 4 and 32 are somewhat cooperative, but 32 is not an exact power, not an integer power of 4. How about if we use a rule 1 and smash this together? I get log base 4 of 2 times 32, or log base 4 of 64. This is the exponent that turns 4 into 64. 4 times 4, 16, times 4, 64. This is 4 to the third. This is like log base 4 of 4 to the third. What's the exponent that turns 4 into 4 to the third? Oh, 3. Okay, this is stating what's the exponent, ln, that's base e. This is insulting once we really understand logarithms. This is the exponent that turns e into e to the 6th. That's tough. What exponent would make e be e to the 6th? 6. Minus 2 times the exponent that would turn e into e to the 7th. What exponent turns e into e to the 7th? 7. Or I get 6 minus 14. -8. Here's another way to look at that. I could have taken this and gone ln e to the 6th minus ln e to the 7th squared, used a rule 3 to bring the 2 in. And now I could use a rule 2 when I have subtraction. That would become ln e to the 6th on this one. Looks like e to the 14th, which is ln e to the -8th. What's the exponent that turns e into e to the -8? Oh, that's -8. So 100, insulting. 3 times the exponent that turns e into e to the 5th. 3 times 5. 15. And 102, remember this, when we have radicals, I'd rather write that as a fractional exponent. This is ln e to the fractional. 5 makes it smaller, the 5th root. 3 makes it bigger, to the 3rd. Now, what's the exponent that turns e into e to the 3/5? Oh, it's 3/5. Somewhat insulting for people like us that understand logarithms so well. Okay, and there is your assignment. You don't want to leave this with any questions. This should be a pretty quick one. If you're struggling with time at all on this one, then you definitely should be coming in for help. We should be in good shape here.